Hello everyone, myself Vedant and Maheshwari.
And myself Hemanshu. We are the students of BTech CSEDS from NMIMS Shirpur.
And today we are going to explain the concept of encapsulation in Java.
So hello everyone, welcome to this video. In today's session, we are going to understand one of the most important concepts of object-oriented programming, which is encapsulation in Java. My name is Vedant Maheshwari, and in the next few minutes, I will explain this concept in a very simple and clear way so that even beginners can understand it easily. So let's start with the basics. What exactly is encapsulation? Encapsulation basically the process of wrapping data and method together into a single unit. In Java, that unit is called a class. Now, what does this mean? In simple words, it means we can keep the variable and the function that operate on them inside one place. Encapsulation also helps in protecting the data from direct access. Instead of accessing variables directly, we use methods to interact with them. So overall, encapsulation is about combining data and behavior while also keeping the data safe. Now going towards the key idea of encapsulation, the main idea behind encapsulation is something called data hiding. Data hiding means we restrict direct access to variables. Instead, we control access through methods. There are two main rules here. First, we keep variables private. Second, we provide controlled access using public methods. This improves security because no one can change the data directly. And it also proves control because we decide how the data is used. So you can think of encapsulations like a protective layer around your data. Now, how encapsulation works? Encapsulation in Java works in three simple steps. Step 1, we declare variables as private. This ensures that they cannot be accessed directly from outside the class. Then step 2, we create getter methods. These methods are used to read or access the data. Step 3, we create setter methods. These methods are used to modify or update the data. So instead of directly changing a variable, we also go through these methods. This way, we get control and secure access to our data. Now, what are the access modifiers in encapsulations? To implement encapsulation, we use something called access modifiers. Access modifiers defines who can access variables and methods. There are three important ones. First is private. It can only be accessed within the same class. Second is public. It can be accessed from anywhere. Third is protected. It can be accessed within the same package and also by subclasses. In encapsulation, we usually keep variables private and methods public. This combination helps us achieve both security and accessibility. Now let's move towards some examples. In simple example. Now let's look at a simple example to understand this better. Here we have a class called student, and inside it we have a variable called age, which is declared as private. Then we have method called setAge, which is used to assign a value to age. And we also have a method called getAge, which is used to return the value of age. So instead of directly accessing the variable, we use these methods. This is perfect example of encapsulation, where data is protected and accessed in controlled way. Now explanation of code. Let's understand this code in a bit more detail. The variable age is private, which means it cannot be accessed directly from outside the class. If someone wants to change its value, they must use the setter method, which is setAge. And if someone wants to read the value, they must use the getter method, which is getAge. This ensures that the internal data is not directly exposed. So overall, this approach helps in maintaining data security, control, and a proper structure of program.
Real life example of encapsulation. Bank account. A bank account is one of the best examples of encapsulation. The account balance is private and cannot be changed directly by the users. Instead, users perform operations like deposit and withdraw using defined methods. This ensures that all transactions follow proper rules and validations. For example, you cannot withdraw more money than your balance because the method checks conditions before processing. This control access prevents fraud and maintains system reliability, just like encapsulation in programming ensures safe data handling. Advantages of encapsulation. Encapsulation provides multiple benefits such as improved data security, controlled access, better code maintainability, and flexibility. Since data is hidden, it cannot be modified accidentally or maliciously. It also allows developers to change internal implementation without affecting external usage. In real life, this is a password protected smartphone where only authorized users can access apps and data. Even if the internal system changes, like software updates, the user interface remains simple and consistent. Disadvantages of encapsulation. Although encapsulation is highly beneficial, it has minor drawbacks. It requires additional methods like getters and setters, which can increase the length of the code. It may also add slight complexity for beginners. However, these disadvantages are small compared to its benefits. In real life, this is similar to secular login system, where extra steps like entering passwords or OTPs may take time, but they ensure safety and preventing unauthorized access. Why encapsulation is important? Encapsulation is important because it protects sensitive data, reduces complexity, and makes large systems easier to manage. It ensures that different parts of a program interact in a controlled and predictable way. In real life, this can be compared to a car system, where users only control steering, brakes, and accelerator without needing to understand the internal engine mechanism. This separation of internal complexity and external usage makes system more efficient and user-friendly. Conclusion. Encapsulation is a fundamental principle of object-oriented programming that ensures data security, controlled access, and organized code structure. By hiding internal details and exposing only necessary functionalities, it helps developers build reliable, scalable, and maintainable software. Just like many real-life systems that hide complexity and provide simple interfaces, encapsulation makes programming more efficient and secure. Thank you.